Here's an example of Teccura's service in action. This is an underbilling electricity lead we found in a large superstore. We calculated the property to use 14,751 kilowatt hours of electricity per day, but the actual billed usage was only 6,755 kilowatt hours of electricity per day. After desktop analysis, it appeared there could be a large amount of consumption going unbilled at the property, so we sent our technicians to site to find the problem. The property has a high voltage supply, meaning there was very little testing we could do on our first visit. All we were able to do was collect even more detailed information to check that our calculated usage was accurate. Once we'd input all the new information, the calculated usage jumped from 14,751 to 16,554 kilowatt hours per day, so it looked like there was a definite problem. It was clear we'd have to get the meter operator to site to test the meter. There were a few problems that can go wrong with these high voltage supplies that can lead them to under-record by such a large amount. For example, a voltage phase reference can be dropped, or there could be a reverse polarity due to current transformer pilot cables being crossed over. A third common issue we've come across are incorrect current transformer ratios programmed on the meter. Let's look at these in more detail. On a three-phase high voltage supply, there are three large cables that carry electricity into the property. Electric current, measured in amps, is drawn along these cables as the property consumes electricity. The meter needs to know the current and voltage to work out the power in kVA. The equation for this is √3 times the average current times the average voltage. The current on these cables is high enough that it would damage an ordinary meter, so the current is reduced to a level that the meter can handle. This is what the current transformers do. Current transformers reduce the current by a specific ratio. In this instance, every 100 amps that is drawn by the property is reduced to 5 amps. 100 divided by 5 is 20, so the ratio is 20. So you divide the amount of current entering the property by 20 to get the amount of current going into the meter. The meter can deal with these low currents, but the meter now needs to multiply these lower currents up to the actual levels, so that it knows exactly how much current is being drawn by the property. The ratios need to be the same on the meter and the current transformers, otherwise usage recorded on the meter is higher or lower than what's actually being used. Let's go back to our supply at the superstore.
Okay, so this is the transformer. The current transformer ratio for the transformer is 200 to 5. The meter is actually set up for 80 to 5. So it looks like it's under recording by 60%-ish.
Once the current transformer ratio on the meter is programmed to 205, the same as the substation, the meter will record all the energy used on site. How could you realise that a property builds 6,755 kilowatt hours of electricity per day, already the same as 650 houses, is actually using 10,000 kilowatt hours more than this without using our complex consumption analysis?